Welcome to this tutorial on creating gussets in sheet metal in Alibre Design. Now, Alibre does not have a tool natively to create gussets, so these have to be created as a separate part in a part workspace, and then they're added as a design Boolean feature by using the model tab and creating a model or a Boolean unite. Now, in order to create this, you need to make sure that the model tab is turned on by going to Tools, Options, and selecting your General tab, and make sure that Show Part Modeling tab in Sheet Metal is selected. So with that said, let me open up a new part workspace and I'll go through the steps of creating this gusset part. Okay, so now we're in our part workspace. We're going to start a sketch on our XY plane, and we'll just grab a rectangle and sketch out a rectangle here and dimension this to be 0.625, and then to make it a square, we'll make this bottom or side and bottom equal, and then we'll extrude this about the mid plane to a depth of 0.625 to end up with a cube. Now if this face and this face are going to be coplanar with the outside faces of our sheet metal part, then we need to put a fillet on this edge equal to the outside radius of our sheet metal bend. So if we design this piece for 14 gauge material and assign the inside bend radius as equal to material thickness, then our outside radius here is going to be equal to 2 times material thickness. So put in material thickness of 0.0747 times 2, and that gives us the outside bend radius. Now, to create the form that we need in here for the gusset, we're going to have a plane in here that we can sketch on. So we'll insert a plane, and we'll grab our YZ plane and our Z axis and put that in, enter at 45 degrees and reverse that so that it splits the angle between these two faces. Then we'll start a sketch on this face or on this new plane, and we'll just orient to sketch plane, and then we'll sketch out a triangle here that will get us the basic shape of our gusset, and we'll put a horizontal constraint here, and to center it on our part, we use a symmetric constraint with this axis and then the two baseline endpoints, and then we'll put a fillet on here. So we grab our two sides, and looks like that's not going to let it, so we'll just move this up a little bit further. Fillet 125, 125. Let's try this again. There we go. Now we have a 125 fillet on there, and now a couple more dimensions. We'll put an angle on these two lines because the gusset, when it's formed, will end up with sloped sides on it, so we'll put in 60 degrees on the sides. And now this baseline, we want that to be tangent to the curve of our fillet, and in order to do that, we're going to grab this outside edge, just the edge of the fillet itself. There we go. Select project to sketch and use a reference figure, and then we'll put a constraint on here coincident from the baseline to this bottom point of this reference line. And then finally we'll get in height for the height on here from the base to the top here, That'll be an outside. And usually gussets are designed between 3 and 4 times material thickness, or no more than 3 or 4 times material thickness. So we'll put this in at 0.18 for height. And let's see here, what's one more constraint, and we need to put the center point of the fillet vertical constraint to the origin, and that'll center up our shape. And now we can do an extrude cut through all, and that gives us our gusset shape. And finally we'll put a fillet on here, and we'll use the same fillet settings as we did for the outside bend radius, just to keep things simple. And that gives us our gusset shape now. And the last step that we're going to do here is do a shell, and we're going to have a standard thickness of material thickness, and then the faces we're going to remove will be everything except for the faces that will be coincident to the surfaces of the sheet metal and this gusset shape. So we'll grab this surface, this one, and this one, and then okay that, and that gives us our gusset shape. So now the next step is to save this. So we'll save this out here in whatever folder you're going to keep all your gusset or sheet metal parts. I'll name this Gusset 1 for this tutorial. And then we'll bring up a sheet metal part, and we'll go to put that gusset part in this. So if we go to our sheet metal tab, go to Boolean Unite, and it'll select our Gusset 1 and bring it in and place it. Now here's what's going to happen. We put in this, we're just going to put this in our sheet metal part, so we'll put some constraints on here. That face to that face, and this face to this face. And now as we move this over, see what's happening here? We can do a Boolean here and unite that piece in here, but it won't show on the outside. It'll only show up on the inside. So the only thing what we need to do is first we'll cancel this. We need to put a hole in this part so that we can put that gusset in as the Boolean Unite. So we'll select this surface and draw a rectangle on it. And just like we did on the gusset feature or gusset part, we'll dimension this to 0.625 and put an equal constraint on here between the bottom and the side, and then we'll constrain this line to the tangent line of the outside surface or outside edge of the sheet metal, and then we'll do a sheet metal cut to a depth of 0.625. Okay. One more thing you can do is we'll edit this sketch. If you want or need to, you can put in a dimension so that you're going to dimension that location of that gusset cutout, and also the gusset position there. Now we can go into our model tab, grab our Boolean part, and place this in the workspace, and now we can add our constraints. Apply that there, this here, and this edge to this edge. Close that, and then commit the Boolean. And there we have our completed Boolean feature in the sheet metal. Now if you need to have more than one, or you need to pattern these, it's important to know that you need to do your patterning for the cutout before your Boolean. So if we want to put 2 in here, let's say we'll come up here and we'll grab our mirror, we'll grab our cutout, and then our midplane for the mirror, and then when we come in and we'll edit our Boolean design and select our Boolean part, and we'll insert a duplicate and finish that off. And now we'll add a couple more constraints to surface on that side and on this side, and then edge to edge, and then commit. And there you go. Now here's the thing about gussets. Once you put these in here, you're not going to be able to get a flat pattern on this part. It's not going to unfold them. So what you need to do is add a new config. So we'll add a new configuration, and I'll just name this one flat and make this active. And then what I'll do is suppress the Boolean, suppress the mirror, and suppress the cut. And now you have a configuration that you can create your flat pattern on. So when you need to show them in your model, just reselect your configuration again, and you've got your gussets back. So that's kind of the short term for making a gusset form part that will work for 90 degrees. So now what I'm going to do is show you how to add some intelligence to the gusset part so that it'll fit into different gauges material and also different bend angles. So with that, let's jump into an edit session on our gusset and add some dimensions to that. Okay, so now here we are. We have our gusset tool back open again, and we're going to go back through this, and we're going to add some parameters in here that we can use to define different bend angles and different material thicknesses, and even modify the size shape of our gusset form in here. So if we open up our equation editor, and that's going to be in your tools menu, equation editor, or Control E, or if you have a menu structure set up where you can bring up a pop-up menu for it. You see a lot of these dimensions are already in here. They're just their standard names, A1 to D1 through 8 and whatever. So go ahead and close that, and we're going to start at the beginning. So let's roll it back to our sketch 1, edit the sketch, and we'll select the D1 dimension, double click on it, and click on FX for the equation editor, and we'll change D1 to call that the flange length. So we'll just call that, or name that FL. And if we tab over, we can add a comment in the comment column. Okay, now this side has a vertical constraint on it. We want to get rid of that. So delete the constraint. We're going to leave the equal on here because these two legs we want to maintain them as being equal lengths. But what we need to do is need to be able to change the angle between this line and this line, which is going to be defining our bend angle in the tool. So add a dimension, and again hit FX. And this one we're going to name bend angle, or BA. again, if we tab over, we can comment that as bend angle. Okay. Hit the OK. There. So now we have flange length and a bend angle. And we want to change this to, if we open up our, do our modification here in the editor now to 90 degrees, just so that we have a common starting point. Okay, then we'll deactivate that. The next one we're going to edit is going to be the extrusion, and here we're going to call this one flange width. And we'll leave that at 625. And now our fillet. We'll edit this. Go to FX. And we'll call this one bend radius, or BR. And now here we have our plane. Now this is going to be kind of tricky. If we edit this, here's where we have to define our something other than the faces to change that angle. So we're going to change this with an equation, and we're going to call this one our bend angle divided by 2. And we want this to remain at minus 45, but what we'll do is BA divided by 2. Okay, that. And okay. Now, see, we didn't reverse it, so if we edit this one more time and hit reverse, then we're okay. Now to test this to make sure that that's going to follow whatever our bend angle is, let's come in here and we'll bring up our bend angle. And let's say our bend angle is 45. Now it changed our angle from this face to this face at 45. And what we should have between this plane and this face, we have 68, and between that one is 68 because our included angle here is 135. So we're maintaining that mid-plane position for this sketch plane between these two faces. So let's go back into our equation editor, change our bend angle again back to 90. The next thing is going to be defining all this stuff for the gusset tool and gusset feature. So this is going to be in our sketch. So these dimensions are going to take on some new parameters or some new names. We're going to have this one. We're going to name this one our gusset depth. Okay, that. And then this angle will be our gusset angle. Okay. And then this one will be our gusset radius, or GR. Okay. And then we're done with that. Now here's an interesting thing that for this fillet, we'll edit this and we can make this one equal to our bend radius. So if we look for BR, and we'll just type in BR to match or to make them equal. So now whenever the bend radius changes, this radius will change too. Or you can assign that a different parameter so that it's controlled separately. And finally we have our shell thickness here. Now here's something that's interesting with shell. Now if we come in here and say our angle is always going to be 90 degrees, well and good. But what happens now when we're going to have an angle of, say, 45? Watch what happens here. So now here on this leg we have a nice face that's perpendicular to the surface. But up here on this face, shell does not shell perpendicular to this face. So that means we need a different tool to create this form. So what we're going to do is delete the shell, and then we're going to go to our surface ribbon and we're going to use our delete face tool, and we're going to select the faces that we had selected for our shell and select those for removal. And the only ones left are going to be the ones that define the gusset shape and the outside surface of the metal or sheet metal body, and we're left with a surface. Next we're going to go to thicken and we'll select our surface, and right now it's giving us an indicator that it's going to thicken to the outside. We want to change that to thicken to the inside, and we want to put that as our material thickness, and OK that. And now we have an edge here that is normal to the surface, outside surface. And then we come down in our surface folder and hide the delete surface. So now we have our completed part here. So if we come back up here and hit our equation editor, change our bend angle to back to 90, and OK that. So there we have our part that's going to follow through bend angles, whatever we need. Now that we added this new feature, we need to come in here and we find our thickened surface, and we're going to change this to MT for material thickness. And OK that. Okay, now one more thing we need to do here. We've got all these parameters named in here, but they're kind of scattered all along in our naming column. And if we sort by name, well, then they're in alphabetical, either one way or the other. So we need to change that so we had them grouped somehow. So what I like to do is I'll put some prefixes on them, and what I usually do is like a ZZ00, ZZ1, ZZ2. That way they'll all stack up at the bottom of the list. You can also do AA, 1 through whatever, so they come up to the top, whichever suits you. But for right now I'm going to use put these in as a ZZ number. So come in and we'll just prefix these, and I'll use lowercase on the prefix. So ZZ0 and underscore. And then the next one is going to be bend radius. So bend radius will be ZZ1 underscore. And then bend angle, ZZ2 underscore. And then next one is going to be gusset depth. So this will be ZZ3. And then gusset angle, ZZ4. And then gusset radius, ZZ5. And then we have flange length, ZZ6. And flange width. So now clicking the name, you get them all stacked up in the bottom. Now it's easy enough to find when you're going to make these changes. They're all the parameters you need are in a line, and it's easy enough to find them. So let's OK this, and let's go ahead back to our model tab, and let's go ahead and save this. Okay, now here's if you have a set of gussets that you know you're going to be using continually or all the time, say in this example is 14 gauge, but say you've got a bend angle on some parts that are pretty common in your production that are going to be always at a certain angle, you can set up configurations. So right now we'll just rename this one at 14 gauge 90 degrees. And so now we'll add a new configuration, and we'll call this one, for example, 14 gauge and 45 degrees. And we'll make this active and OK it. Then come into your equation editor, and we're going to change our bend angle to 45 degrees. So now we have two configurations in our gusset tool, 90 degrees, 45 degrees. So you have another one that's going to be at 135 degrees. So I always like to start my configurations with the base config. So we'll add a configuration here at 14 gauge, 135 degrees. Make this active, and then again come into the equation editor and change the bend angle to 135 and OK that. And now we have our gusset tool at 135, and our bend angle is still the same, and it's formed up. So with that, let's save this, and let's take a look at how this is used now. So if we open up a part that's got some bends on it that need to have gussets added to them. So we have a 45 degree bend, we have a 135 degree, and we have a 90 degree. Now remember, our cutouts are going to be 0.625, that's the length of our legs. So if we start a cutout here, and we'll add a cutout, and dimension this to 0.625. And because we know our legs are going to be the same, we'll just add equal here. We'll center this on the part with a symmetric constraint. Select our mid-plane axis and then our two edges, and then finally a collinear from this base to that edge, and finally a sheet metal cut to a depth of 0.625. Okay, and now we just go out here and we'll go to our model tab, do a Boolean unite, grab our gusset tool, place it, and let's go ahead and constrain this in place. So this face to this face, and we'll flip that and apply it, and then this face to this face, apply that, and then this edge to this edge, apply that, and then we'll commit the Boolean. So there's one. But now let's say we're going to add gussets to these other two. So what I like to do is make sure that my cuts are going to be on the two faces. And now this, we can't use a straight cut like we did on this 90-degree bend. So what we're going to do is we're going to start a sketch on this midplane, and we're going to draw basically a triangle and then we're going to constrain this to this face, and this one is going to get constrained to that face. We'll make those legs equal, and dimension it at 0.625. Grab the wrong line here. Let's try this again. There we go, 0.625. And now this time we'll do a sheet metal cut, mid-plane, 0.625. Now, because my sketch is on the outside and sheet metal is always going to cut normal to the surface you're cutting from, it doesn't matter that your sketch does not go through the sheet metal like you normally would, like on a part. So we'll just OK this, and then we'll do another one on this face over here. Actually, if we can come back here, we'll edit this sketch so we have them both in the same sketch. We'll do some lines, and again we'll constrain these, this one to this edge and this to that edge, and we'll make them equal, and 0.625. And then deactivate, and since they're under the same cut tool, we have that form cut in there. Now, actually this cut should have been above the design Boolean, because what I'm going to do now, we'll edit the design Boolean, and I'm going to right click on this gusset, insert duplicates, and place two more gusset tools here. Okay, now for this tool I need to expand this, go to configurations, and activate the 45-degree angle one, and we'll constrain this in place. Couple of constraints there, and we'll slide this over so we can get access to this face and that face, and apply that and close that. Okay, so now we can minimize this. Now this gusset tool, expand the configurations. This one we need to activate 135, and we'll constrain this this face to this face, reverse it and apply that, and then this face to that face, now let's see what's here going on here and here. Oh, I see what's going on. Apply that, close. We'll edit this and reverse that, and then edit this and we'll reverse that, and then finally we'll do this to this, and one more time we'll edit this and reverse. Actually, no, we'll just delete this one and reapply. Get this one in here correctly. There we go. Okay, now what we have here is 3 different gusset angles, all from the same tool, all in the same design Boolean feature. And there's our completed part. So anyway, there's a short preview, how-to, whatever you want to call it, on how to create and apply gusset features to your Alibre sheet metal components. So if you have any questions, post them in the comments. Thanks.